Oh, sorry, it did not record. So I forgot to push. Now let me start about this. So we are going to focus here on control chart, and basic theoretical part you can read. However, I'm just going to talk about little bit about people, those who contributed in the quality field. And this concept started, this discipline started in early 1900. Quality took the form of improved inspection and improvement in the method of mass production. So it is started with the industrial, and 1920, Walter Seward, he started the control charts. Then 1950 to 1960, Deming and Juran, these are the two great people, and they were trained Japanese manufacturers to become high quality producers by applying American quality control techniques. So if you go into American quality control website, you will get to know a lot of updates and information about that. If you are interested, you can pursue black belts. There are multiple belts in quality control. Six Sigma is part of the quality control. So then Taguchi and Ishikawa, and they also trained Japanese manufacturers. So this is how this started. 1970, North American firm had lost their initial leadership in quality control, and Japanese, devised and perfected new quality improvement methods. They developed, Kanban and different other methods. Deming, Juran, and in 1980s, then this further development took place. Deming, Juran, Ishikawa, Kaizen, and then European introduced ISO standards, different standards, 9,000. Now we have different ISO standards. So these are the fathers, so these are the people, those who started and contributed in the field of quality management. It's your reading. These are the 14 points suggested by Deming. And maintain consistency of purpose. So again, it's related to reading. It is published in MIT. So you can see. Now we have statistical quality control. And these are the tools for statistical quality control. And in previous classes, you studied a scatter plot, box plot. I'm going to talk about fishbone, check sheet. When you have control charts, we are going to look today. Sampling, batch inspection plans. So basically, Pareto diagram we studied in 503, 80-20 rules, and fishbone diagram, which is cause and effect diagram, or fishbone diagram, or Ishikawa diagram. So we are going to look into all this. Measuring quality, there are some examples you can go through. And now you look into the quality control tools that we used in our course, past course. So this is Pareto chart, which is called 80-20 rules. 80% of problems are due to 20% of causes, or 80% of effect can be control, or can be enhanced with the 20% of improvements. So this is also called 80-20 rules. And here we have the option under mini tab, go under statistics, go under control charts, quality tools, and we have Pareto charts option here. We have, fishbone diagram option also that you can develop using mini tab. Here you can go, and quality tools, and here cause and effect or fishbone, same. Many other things are also here. box plot, you can clearly see we learn in I think 503 module 2. So check sheet, which is like, you keep all the items or all the inspection things and you check this. So fishbone chart is also cause and effect diagram or Ishikawa. It is very important if you are really facing any problem or if your organization facing any problem. This is the best starting point to look into the problem and understanding the root cause of the problems. But it is not a statistical tool, but helps in thinking about root cause. So very important for management problem solving. And a statistical process control chart, we are going to look majorly this part. So basically this is a fishbone diagram, and I think this is the effect. What are the causes? People, method, material, management, measurement, technology. It could be, it could be other factors too. You can include all under people. What are the problems that you see? What are the problems? And eventually that will result into this. So this is called basic and very important to start understanding the problem. So quality improvement program, many organizations have now. Total quality management means quality in everything that we do. So that is total quality management, and some of you are already or might be working. Business process re-engineering, there would be a problem in business process, then re-engineer. And Six Sigma, and it's based on define, measure, analyze, improve, and control. So these are DMAC. Six Sigma means, if you remember or if you know, that Six Sigma means it was started by Motorola. Motorola developed this concept and they said, 3.14 defects per million. So think about UPS and thinks about FedEx and, big companies. They are shipping the parcels out every day. They are shipping almost 1 million parcels. And if you think how many parcels are not reaching on the destination on time or not, or misplaced or something, out of 1 million, it would be about 3-4 items, or even less than that, or about close to that. So Six Sigma is like, this. So it has these define, measure, analyze, improve, and control. And once you complete black belt, Six Sigma black belt from American Quality Association, you can write your own checks. And Six Sigma is not only in production or physical products. It can be in quality, it can be in healthcare, it can be in many places, everywhere, education and other things. And I can give you one simple example. GE is another organization which use Six Sigma. I think nowadays every organization use Six Sigma in order to control, call centers. Call center they use in their service quality of the calls, whether satisfied customers are satisfied, their problems are addressed or not. So this is one of the thing. And in India, since you are in healthcare industry, I would like to share one example. Because I see many of his students here are from healthcare industry, and when I read their this discussions, I can clearly understand. And this is the organization, Devi Sethi. Just sharing. So this gentleman, those who are healthcare professionals, they might know about this gentleman from India. And he has a organization called Narayana Hridyalaya, which is a chain of hospitals in India. And will you believe that, a couple of years ago, they were able to do a open heart surgery within $1,000, including a 7-star kind of facility in the hospital. And now, Narayana Health, I think this is the hospital company, I think, yeah. So this is the company, and they are using how they are optimizing all the processes, minimum base stage and all. They can do, bypass or any heart surgery. I'm just giving a heart surgery example because I read that case, and I guided one PhD in healthcare also on healthcare governance in India. So this is the case in $2,000 open heart surgery. Therefore, medical tourism is a lot of taking place in India. And similarly, we have Arvind Eye Care. This is another hospital. Yeah, Arvind, this is, my student did a PhD on keeping case study of this Arvind Eye Hospital. It is a, good chain. And, in less than $2 to $3, about $3, when she completed in 2015, they can do eye surgery in less than $3. And that is out of, million patient, only 1 or 2 can be not quality surgery or can have after surgery some impact, but 99.999999999% are perfect. So in less than $3. So because they are using, their processes are so optimized, so things. And here, if you so this is just, I wanted to share some example from healthcare industry point of view. Quality improvement programs, quality total business, I think, yeah. So now we are coming on control chart. That is important for our assignment. And we have just 5 MCQ. When you read the chapter, you will finish it. When you read, there are 10 questions. Out of that, only few are numerical questions that you can easily understand. So now you have very less load for this week and next week, because I will give only 5 question or 10 question, or not much, very simple. So here, what is control chart? Control chart is a visual display that plots the values of sample statistics over a time through repeated observations. So when you have, when industrial thing, if they would like to check the quality of the product is in control, how they do it, they go and they take one sample. First, they take randomly one sample, or let's say 10 pieces. Then after an hour, they take another 10. Then after 2 hours, during 24 hours, they take 5-6 batches of sample. And they inspect whether those are under control, their quality is in control or not control. So control chart display a measure of central tendency, which is mean, and variation that you remember from previous. So the subgroup size of numerical data may be quite small, even a single item. So you can see there are 3 types of chart. X bar chart, which is a control chart for means X bar, run chart, a control chart for sample range, that is run chart or R chart. P chart for proportions. So these are the 3 common charts we use in this. And there could be 2 types of data: attribute, qualitative, can be also possible. So now look into this chart, these charts. I'm just making it bigger. So this is a mean, and you can see mean, upper control limit, and lower control limit. So upper, lower. If chart is within that, you can see the process in control. But there are a few rules you need to remember. So here. So this is upper control limit is plus minus 3 sigma, standard error from the central line. So the empirical rule says, so basically the same concept, upper control limit equal to mu plus 3 sigma upon square root of n. Lower control limit, same concept that we learned in the past, 3 sigma square root of n. So these are the upper and lower control limit. Mean, you know what is mean, mu and sigma. So now most important principle I would like to share here, that this slide is very important because some questions will be based on this, may come in exam too. Single point outside 3 sigma. These are the thumb rules. This is a very important rule, very first. So if you see this, this is mean, this is 1, this is 2, this is 3, 1, 2, 3. So single point outside 3 sigma. So if anything beyond, so this is the case, because here you can see 1 point outside 3 sigma. This is rule number 1. Rule 2, 2 or 3 successive point outside 2 sigma. So now question is this. So this is 2 sigma, this is 2 sigma, and 2 or 3 points are outside 2 sigma. This is rule number 2. Rule number 3, 4 or 5 successive point outside 1 sigma. So this is a 1 sigma. Oh, sorry, this is 1 sigma case, and this is 1 sigma here. So here you can see 2, 3, 4, how many? Oh, sorry, this is 1 sigma, sorry. So this is 1 sigma line, and this is 1 sigma. You can see many points are outside 1 sigma. So rule 4, 9 successive point on same side of the central line. So successive point, this is a central line, and you can see these are the successive point outside, or you can say here also. So these are the 4 rules that you need to remember in order to make decision. And so detecting abnormal patterns, these are the 4 rules. Okay, 1 point outside 6 sigma, okay, you can consider, but other things you have to check in your process so that these defects or these quality can be controlled. Otherwise, you are making a product of 100 gram, it can be 110 gram, and you will have a lot of wastage, and the product, the wastage and the cost of the production will increase, and many other things. So these are the control chart. Now I'm going to talk about, this is a proportion. As you know, what is the proportion formula? X upon n. This is pi plus, this is the formula of proportion. And now I'm going to work on Minitab. So there could be a different patterns: cyclic, oscillation, instability, level shift, trend, and mixture. So here and this is another important thing, very important thing that you can remember. CP index. What is CP index? It's a capability index, which is a ratio comparing interval between specification limits with expected process range. So CP upper SL minus lower SL upon 6 sigma. And this is called capability. And it has some, if CP equal to 1, indicates the process is just barely capable of staying within a specification if precisely centered. So manager typically requires CP is greater than 1.33. So this is another important concept. And you can see from this slide, because you will get some questions from here. Look into this. So how you can check whether there is a safety margin or not. And here, CP is 1.67. CP is just 1. Look into this. CP is 1 means you don't have safety margin. Little bit swing in the process or quality will result into defective product. So here you don't have margin. Here CP equal to 1.3 means this is the margin you have. This is the margin you have. Once CP 1.667, you have more margin for that. Little bit abnormal activity will not result into, and here, so CP, higher is the CP, better is the, better you have some margin. So now I'm going directly on Minitab. So first thing first, I'm going to start here. So let's see, I'm going to make fishbone diagram that can be used. So I'm just using M1. These are the different causes. M2, M3. So you need to write, you need to put here, different. So M1, I'm just writing, I don't remember the names and other things. M22, these are the different reason. I'm just coding 33. M44, similarly here, I'm just writing M104, M105, M106, and M107. M201, now you can create a very good fishbone diagram of the current situation that is happening. Failure of Silicon Valley Bank. So it could be, regulator issue, it's a debt, other issues. So you can write here, and then you can write all the causes, and then you can make the fishbone diagram. Now I go here and I go under statistics, where's the quality tools, and here I have cause and effect diagram. Let's say these coding are different. So causes, I just do it here. And then effect is like failure of bank. I can write the titles, and now I'm just going to oh, I need to do something here also, otherwise. Quality tools, cause and effect diagram. Just a minute. I have to put, 5th and 6th. So M5 and M6. So M401, M402, M403, M501, M502, M503. And now I go under quality tools, cause and effect. I hope this will work now. Something is, so last attempt. And oh, I have, I can put the subgroup also. These are the thing underneath. I can put some other things. So I can put some other inside M12, M33, and which I'm not putting. So basically that is why this is causing a, but how can I? And that's why it is not coming. Okay, I will make a video and I will share with about this. Oh, so you don't have cause and effect. Are you using window or something? So I will make a video about cause and effect and I will share with you. Now, after that, the second option is control charts. Here, very simply, if you go under assistant, if you look into control chart, here you can see all the options. Data type, it's a continuous or attributed. Attributed, so you can use P chart, you can use U chart. We have only P chart in the thing. Now here you go under continuous. Data collected in subgroups, yes. If the information, yes. Then subgroup size is less than 8. So how many subgroup size we have here? 6. Okay, we have less than 8. Okay, then we can use S bar and run chart and X bar and S chart. So we are just going to use this. Let's do this, and I just do, and I select here, and I just, I can estimate, or I can put my own information, estimate from the data, and I just do this, and I get the answer. Now tell me whether this process is this is a mean. This is the mean. X bar chart is upper control limit, lower control limit, X bar value, and you can see this process in control or not. And do you think any rule is applicable here? Do you see any rule is applicable? Rule 1, 2, 3, 4. And here I can see these 3 numbers. I mean, this may be within one standard, but probably. Okay, so I don't think any violation of any rule is applicable here. So this is one thing, this process in control. But if you see, this is the range, and you can see. So basically, this is X bar chart. The same option is available through stat, quality, and here you can have run chart. You can have run chart here, status, quality tools. Yes. So control chart. So here you have a control chart option, and here you can see attribute charts, variable, here IMR chart, X bar R chart. So let's see, let's see. So here I go to 1 to 6. So here they are in this. You can define here, you can define the labels. Here you can define this, but here you have one thing, you can define the mean, standard deviation. You can put the limit also, lower standard deviation limit, upper standard deviation. So this gives you more option when you want to do some customized thing. But in our course, I just wanted to give some information. You can use also help, assistant one, and you can get. So number of subgroups, I have 6. And this is giving for each of them, because this information is given for complete 6, and it has pooled in from a standard deviation. Pooled standard deviation means the standard deviation of all 6 subgroups, and pooled mean means mean of all 6. So basically I answered 2 questions of fill in the blanks right within few minutes. So this is the best option. If you go under this and select which option you want to do and select, and you can get. So this is about control chart, and which chart is asked, whether you are asking X bar and R chart, you are asking U chart, you are asking P chart, X bar and S chart. So this is, all these charts are right here, and you will get the data to run these charts. So very simple. And this week discussion is about nowadays we are using industry 5 in everything. I think if I'm asking the correct industry 5, you know what is industry 5? So industry 5 is about human is working with robots, human is working with machines and technology in order to get it done the job. For example, doctors are using robots to get it done the surgery. Now I recently, few days ago, I was watching a video in local news on that one of the hospital in Spokane, I think Providence, or I think Dickinson Hospital, has a robot nurse. That nurse is helping other nurses, or helping to get patient care things very simple, and I mean the workload is reduced of other nurses. So basically industry 5 is nothing but how it can impact the quality control, how this will impact the quality control of the industry. So this is the discussion. We don't have any numbers in here. You can just share your free flowing ideas, and that's what is the discussion. So this is about this week, and if you have any question, please feel free to ask. If you don't have any question, I would like to say again that we will have the exam available. So let me write here, and I'm going to post the message, in announcement also. Exam will be available on 25th, which is Saturday evening, and it will last till Sunday on 25th to 26th. 25th, 6 p.m. And the final module I will open on Friday, this Friday, and I will take the class also on this Friday at 6 p.m. Those who are free, please join, because this is out of the course, but it is very interesting method that can help you to do multi-criteria decision making that we always feel in our life. We have many options, which one to pick up. Okay, this house, we are going to buy a house. Okay, this house has good location, this house has newer construction, this house has the garden is good. How to decide which is best? So multi-criteria decision making, or when you buy a car, you have 5 options, which is the best. So we are going to learn that, and all you are busy doing some kind of projects in our life, or we are always busy in doing projects. How to manage project and how to estimate the project duration. Is it beyond, it is going to be late, or it is going to be finished earlier? So we will learn in last module, that is not covered in the book. So I'm going to make some changes, and it will be available on this Friday. And I will make exam related announcement in very soon. If you have any question, please feel free to ask. If you don't have any question, I would like to say have a wonderful evening, wonderful, productive week ahead to all of you. And we'll meet on this Friday. If not, and those who, yeah, so now let me stop the